Hi and welcome back. In the last video, we discussed the slope-intercept form of a line, and we left off with an example that was similar to the one you see here. Let's do a quick recap of what we learned so far. We've learned how to find the distance between 2 points on a Cartesian coordinate system, and we've learned how to find the slope of a line. Then we threw in an additional skill, and that is, if we're given the slope and 1 point on the line, how we can find the equation of a line. That brings us to the point-slope form of a line here. This is very much related to finding the slope of a line, or the distance between 2 points on a graph, except that instead of finding the slope, we're trying to express the formula of a line from 2 or more points on that line. Now, as you can see here, this is a point-slope form of a line, and it should look very familiar to you, because basically all they've done to get this formula is to multiply both sides of the slope formula by the denominator, which is x2 minus x1. So for the slope-intercept form of a line, we were given the slope and 1 point. This problem is really not much different. The only difference is we're actually taking the 2 points and calculating the slope ourselves, and then we can take either one of those points and use that to create an equation that describes that line. So let's go through an example here. We're given the points 0, 1 and 1, 3. You can disregard the dots here. Those are just extra points on the line. But you can see that when x is 1, we have a y value of 3, and when x is 0, we have a y value of 1. So to find the slope of this line, if you were given the graph to solve the problem, you could deduce the slope from that, because you see that in going from x is equal to 0 to x is equal to 1, that's the run, the y value changes by 2. So you know the slope would be 2. But if you want to calculate it, and you may be asked to on an exam, you could use the 2 points and calculate the slope. And we'll take a look at some examples after this, but here I just want to illustrate to you that when you have the equation, you can actually show that both of these points are on the line. So if you take point 1, which is 0, 1 here, and we know what the slope is, you can get the equation y is equal to 2x plus 1. Alternatively, if you take point 2, that is 1, 3, you can fill in those values to the equation. When you do the math, what you ultimately get down to is that y is equal to 2x plus 1, and that agrees with the calculation we did for point 1. So again, there's not a lot of difference here between what we've already been doing, so it's sort of a natural extension of what we learned up to this point. So let's find the formula of a line when we're only given 2 points on that line. First, we would calculate the slope ourselves. So we know that the slope is equal to the rise over the run, which is the difference between 2 y values divided by the difference between 2 x values. Here, if we take y2 is equal to 6 and subtract the y value of 0.1 from that, which is minus negative 2, we get positive 8 for the numerator. Take 0.2, whose x value is 1, and from that subtract a minus 3, we get a positive 4 for the denominator. 8 divided by 4 is equal to 2, so now we have the slope and we've actually calculated it. So on an exam or quiz, the problem would go something like this. They give you the 2 points and they want you to find the equation of a line described by those points. Now, just as an example before, we've done that with each point here. On an exam, you would only need to do 1 point, but testing the second point is a good way to check your work. Let's use point 1 to see if we can find the equation of this line. We have our formula, which is the difference between the y values, y minus y1 is equal to the slope times the difference in the x values, or x minus x1. So if you fill in point 1, we have y minus negative 2, which becomes y plus 2, and we set that equal to the slope, which is 2, and then in parentheses times x minus a negative 3, which becomes x plus 3. So what we have up to this point is y plus 2 is equal to 2x plus 3. If we use the distributive property and multiply that out, we get 2x plus 6. So now to isolate the y on the left side of the equation, we subtract 2 from both sides. On the left, the 2's cancel out, leaving us with just y, and on the right hand side we get 2x plus 6 minus 2, or 2x plus 4. Now for point 2, the slope is the same, so we just fill that in, except this time we use the 0.16 for the x and y values. So on the left hand side we get y minus 6 is equal to 2, and then in parentheses times x minus 1. Multiplying this out and simplifying, we see that y minus 6 is equal to 2x minus 2. If we add 6 to both sides, it cancels out on the left, leaving us with just y, and on the right we get 2x minus 2 plus 6, which in the end brings us back to y is equal to 2x plus 4. So we can feel pretty confident that we worked this problem correctly. Another thing we can do with this information, either by graphing or solving mathematically, is to find the intercepts of the line. So here's a good question. If b is equal to the y-intercept in the slope-intercept form of a line, what is the x-intercept, if any? Well, to find the y-intercept, we let x be equal to 0, and then we solve for y. If we do that here, we can see that when x is equal to 0, y is equal to 4. But let's say you're asked to find the x-intercept. Well, that's simple. Instead of letting x equal 0, you let y equal 0, and then you solve for x. So here, we have 0 is equal to 2x plus 4. If you subtract 4 from both sides of the equation, you end up with negative 4 is equal to 2x. Negative 4 divided by 2 is negative 2, and so the x-intercept occurs at negative 2, which you can see from the graph here. When y is equal to 0, x is equal to negative 2. Okay, let's go ahead and take a break here. When we come back, we'll talk about how we can determine whether two lines are parallel or perpendicular, and then we'll move into inequalities.